Hi everyone, it is Azure Thursday again. And tonight we have an amazing evening together with the Build community from Pitfalls. And we have three amazing speakers tonight as well. And this is our last full virtual event because we are shifting to in-person or hybrid events. And this gives me also the opportunity to announce our next event, which is going to be an Ignite viewing party organized together with several Dutch communities on November 2nd in the Jaarbeurs. We will start spreading the word tomorrow, so keep an eye on our meetup channel and our meetup emails so you can order your ticket. So Esther, it's time to introduce our first speaker, right?
So, have a full right, and I'm going to Arya Newtonhouse. And well, I think definitely a great. So, Arya,
Yes, of course. So welcome you all, and thanks for having me. My name is Arya Newwenhuis, and I will shortly introduce myself in my slide deck. I don't know if my slide deck is already showing. I don't think so. Can we put that on up? Yes. Okay, very good. So something about me. I'm Arjan Nieuwenhuis. I'm software and solution architect at Capgemini. I studied computer science in University of Utrecht. Did a master thesis there as well. And from there on started at Capgemini as a developer first. A bit ashamed, but yes, I started off as a Java developer. In a few months, I switched to more mobile. And since then, I've been mobile developer, mobile architect, and building up to solution architect, what I am today, related with a lot of new technologies and cloud. On the slide, you see my family. I'm quite proud of it, and I love to spend time with them. And so that's a big cheer. Further, I like to tend my garden and grow my own veggies. So I like to see things bloom and grow, and that's also from a professional perspective something about me. I like to see that. So shall I continue with? I think so. So let's head on to the topic at hand. Tonight, I want to tell you something about Visual Studio App Center. I will tell you a little bit about the world of apps, the challenges we are quite all facing when we talk about apps, and what key features does Visual Studio App Center bring us to speed up things and also to make our life easier. So the world of apps. You all know the familiar ones, right? So building apps for Apple, for Android, for Google, and for Windows, Microsoft. So that's the usual stuff, right? So you can have iOS apps, iPadOS apps. You can even do macOS and tvOS. Android, of course, with Java and Kotlin underneath. Windows apps, universal platform, but also still WinForms. Where it gets more excited, I think, personally, is the world of multi-platform apps. So what can we do to have one single code base, and from there on distribute those apps to the native stores? And we can do it with React, we can do it with Xamarin, of course, And on top of that, quite new feature is also the apps that Unity bring to mobile, so to enable mixed reality on your mobile via App Center, of course. The whole thing about those apps is that in general they are multi-factor. And what do I mean with that? Is that you have millions of devices, of course, and you have certain streams of devices. And those devices tend to have different form factors. And to cope with that, the whole world of mobile is or restricting the number of devices and the way how they present themselves and limit the form factors, or you come into the realm of more web-like responsive apps, which take up more space when there is more space to take. And I will come back to that in a short while as well. So that's more on the device side. On the distribution side, we all know, of course, the public stores and the Play Store, the Apple Store. And but what you don't know or might not know is that there's also a world in private stores. So we call them enterprise stores. Generally, one of the main contestants on that part is Intune. But you could also think of other mobile device management suites, which provide a certain enterprise-like store where you can store your Android apps or all of the others, all other kinds of apps. The challenges we're facing. Managing multiple apps tends to get big quite fast. And what do I mean with that? Of course, you have the multi-stages. So we have a dev environment with a certain level of apps. We have test environment, we have staging, we have production. But we also tend to have apps that are rebranded. So you multi-tenant apps, or we have multi-platform apps. So which target a whole scala of different platforms, which brings me to the discussion on, or at least it brings me to all the moving parts, because all those platforms that are already mentioned, so the big ones, Apple, Google, they are whole ecosystems, and they all have similar functionality, but they are tackling it in a different way. And that means that you have, although you have one code base, there's a lot of learning. There's a lot of expectations you need to meet. And there are a lot of moving parts when it comes to, for instance, something quite basic of the signing certificates you need to be able to distribute your apps. I will come back to that on that one as well. So how can Visual Studio App Center make our life easier? We incorporate Visual Studio App Center because it helps us in the four main stages of your app. It helps you and guides you within the building steps of your app. It guides you and helps you with testing your app and bringing and distributing it, sideloading it to certain devices. And furthermore, when it's in production or in a certain stage and you want to monitor it, you can use App Center to track it, see the usage, see the crash reports, but also zoom in on certain level of analytics that we can do. I will not have the time to show you everything. But therefore, I just picked some small things, and that gives also some room to make it a sequel or a revisit in the future. So let me yes, stop my slide and let's show what I prepared. And this is always quite a challenging one. I hope you can see this all. I will zoom in a minute. At least I tend to. It is not zooming. Okay, that's a bit awkward. So let me first say that I started off with a new project, and it's not something fancy.
Arjan, can you please zoom in a bit?
Yeah, I'm trying, but it's not zooming. I should also be able to zoom in via Teams, right? Yeah, maybe that will help. Maybe I can here. Let's do some pinching then. Let's do it this way. So let me make this some bigger. Is it getting better? I hope so. So what we see here is a Xamarin Form solution. We have an iOS and an Android component. It's just new, and you can easily do this. And you can start off with just state files, new project, and I took the liberty of doing a flyout app, and I modified it a bit for this particular case. So what is important, of course, is to manage your NuGet packages. You need to add your App Center. I will show you in a bit. So you need to install certain NuGet packages to be able to use Microsoft App Center within your solution. And I do this particularly because I wanted to demo what you can do on crashes and analytics. And in a minute, I will also step over to App Center, the platform, and introduce what steps I took there. I hope you can all also read this. So let me show you quickly what needs to be done. So you have a project. You want to introduce some crash analytics or some other analytics of Visual Studio App Center to monitor your app on the App Center suite. There are multiple approaches, and if you go into the bear with me, guys. I'm on preview. Okay. Let's do something different. I will come back to the solution. Let's first start off with App Center now. So I started the solution from a technical perspective in the Visual Studio project. This is the main view on App Center. App Center is the suite we are talking about today, and I added, just to show the capabilities of the platform, I added 2 apps. I will only really show the Android app, but the iOS app is there as well. I can show it in a minute when I have my simulator up and running. It's as simple as adding an app for a certain level of stage you want to start. Just select what you need. In my particular case, it was Android, of course, and I chose Xamarin. But there's also a route you can take, and that's doing iOS, of course. Here you also see already what kind of support you have from App Center on the certain topics of apps. You see a whole scala of apps. We have Unity in here, we have Xamarin in here, we have Cordova is in preview, React Native, and of course the Objective-C and Swift. Well, for Java, we have Kotlin and Java for Android, of course. And we have UWP and WPF and WinForms and Unity for Windows. So I selected, I created those apps. And so you can, from the platform, you can build the apps, you can test the apps, you can distribute it, and you can distribute it 2 ways. You can use App Center as a side-loading platform to be able to use on devices which aren't registered anywhere. It has some pros and cons, of course, and not everything is safe. But doing this in just a test and dev environment really speeds up things. So I can recommend that. And from there on, you can also distribute it to the stores. To do so, there are some things you need to be to take in place, of course, on the stores itself. And you need to pre-register your app and those kind of things. You set up your signing certificates and all those kind of things that you need. But when they're all in place and you have incorporated them into your solution, you can choose to build it locally and just upload the package. But build gives you also the possibility to hook up with any, well, not any, but the most popular repro platforms that we currently know. So Azure DevOps, GitHub, but also GitLab and Bitbucket, so the Atlassian suite. It works also the other way around. So you can also have extensions. So for example, I have Azure DevOps environment, and from there, sorry. So I have a Azure DevOps environment. From the Azure DevOps environment, I created, of course, a project. I have a Git repo in place. From there on, you can also define your pipelines. I haven't done that right now, but I wanted to show is that you can easily hook up with your repo, state, hey, I want to build an Android app. And from there on, this would be your typical YAML. When you show we'll zoom, try to show you this. When you open up the task assistant, you will also see that you have tools to link up directly as an extension of your pipeline to distribute it and configure it for your pipeline, for your App Center. Sorry. So it needs some information. I will not do that right now, but you can mention that the outcome of your pipeline, that kind of archive packages, is then distributed to certain groups, certain builds in your App Center, representative of the app. So having done that, you can also test your apps. I will not do that right now, but I will just wanted to show you that you can create, start testing your app. Okay, well, you can do it on a lot of mobile apps. So you can, for instance, see that you have a whole spectrum of all kind of apps which you can run your app on and test it. And it goes for Android apps, but it goes also for certain Android levels and all the things you need. Mind you that running these apps and running them on all kind of devices is quite costly. So it is advisable to use not the usual suspects or and target and zoom in on certain problem areas that you have received from the crash analytics within App Center to target down to a select number of devices where you want to test it on. Yeah, distribute. I will come back to that one. I mentioned already some diagnostics. So of course I modified my app, and I modified it a bit so that we could see at least some crashes and some errors. I'm just raising some test crash report, so that's not that fancy. But yeah. Let's just see. I will switch back to the code again. I hope it's working. So just let me. Oh. I really thought I made some sacrifices to the demo gods, but they are not working for me today. So let me quickly shut this one down. Try again. It's trying to start up Visual Studio. 1 sec. It's really trying to start up a preview. Separately, I will also start Visual Studio, the older version. See which one's quicker.
Just updated it, so it's kind of teasing you with the new functionality. Arya.
Exactly.
Oh. Help you with something.
Nope, no updates today. I'm good, thank you.
Yeah. Or can we help you with something?
Oh, it's starting up, but it's starting out. Okay. Maybe it's way too small for you guys, right? So I will try and close this one down a bit. I was just wondering, so I am trying to go and zoom in again. And I will do it with a pinch, and that should work. Oh, this is, okay. Can I do it this way? No. Ah, here we are. So this feature wasn't working in the preview one. Okay. Just for the sake of argument that we have, and that I've done my homework, I will start up the iOS build. It will show in a minute. And from there on, I will also, this goes quite fast on a Mac. Here it is already. So the demo app I just adjusted, it's just a flyout, nothing fancy. The only thing I had built in is that I reused the login page for being able to trigger. So if I click this button, it will trigger App Center, and it will show a certain log, and then go back to this starting page. And I give it let's give it some time for the events. Sorry, should have been here. So this should be, no, it's not the one. Okay, let's just settle this one. I will switch over to Android. I will pull in my Android emulator as well. Where did it go? Ah, here it is. So we have same app now within the context of Android. What you see is the flyout is then replaced with a menu bar button. Same triggering can take place. So I will also click it here. And I will refresh this one. And last day. See if it comes in. No, it's an old one. It's a new old one. So it takes some time for these to eventually be able to be logged. And I have an error here. Yeah. Okay. Well, at least I can. Okay. Well, the rest of the what I adjusted in the app was something basic. So if we just browse, we get a nice a detail page. So a list page, and we click on it, we get a detail page. And every time I click on this, it states which item I selected. And stores that back to the analytics part of Visual Studio App Center. And the other thing I did is when I add just an item, I can just add an item, say hello and hello Azure Thursdays. It's just been added to the list. And if I click it, it will have the detail page, and then it will also add. Giving this, I send some information via this app, just plain to see and show you all these nice kind of reports that come out of it. So in general, we have the issue tracker, so it sees about the health and the usage of your app. Sorry, the health of your app. You can zoom in on certain levels. As you can see here, I will make it a bit smaller. You can select some time difference. You can select certain build numbers. You can select the version of the app. And regarding the number of issues, you say the number of accounts, how many individual users have been influenced. And when you distribute your app and you also add some symbolics, you get even crash reports that can drill down even to the classes. So it really helps you find out where things go wrong and what you need to address. And it could be that there are certain devices where this is applicable, and then you can do, for instance, a specific test via test clouds on those kind of devices that have been hit. So if I zoom in on this one, this is not the current one. Although it's hard to see because of course, I'm on a Apple Silicon MacBook currently, so it will add up as a Google emulator. So I can not really differentiate but you can see when it's happening. So this is typically not now. So when you monitor your app, you want to also see, hey, how many users do I have, and how many users do I have monthly, weekly, daily, and those kinds of information is easily displayed. Further, you see how long certain sessions are doing, what the top devices are that you are currently using your app. And you can also see what kind of OS levels and those kind of things where they are on. Current languages, of course, but also, and that's nice to see, the geography or of the usage of your app. So currently, I don't know why, but most of my services are being routed via the United States. And you see one small dot here in the Netherlands, and the other ones are unknown. So yeah, let me quickly proceed. I mentioned already the count on the details. Hopefully, the one that I'm looking for is in here. I added, of course, certain ones. And if I scroll down a bit, I hope you can see that as well. I should be able to. No, let's not do that. Can I see it? Okay, and I go here. An item has been added. So this is the raw logs, and they tend to go a bit faster than the displayed nice portal ones. But as you can see here, I stated I added an item. And furthermore, I clicked on it to display the hello and the hello Azure Thursdays. So that at least shows it's working. So that's nice. So if we go into the details on the which details I've been clicking, we can see it as well. And here you see, for example, I had a text called hello, and which was part of one of the things I've been clicking. And you see, well, this is just some random GUIDs associated with those items. Every time I spin up, there are new GUIDs being displayed. But you can imagine that using this kind of technology, and you are free to add those analytics. Of course, there are limitations, but on certain level, on certain specifics you want to target, or you want to know something about the usage, how do people use your app within the app, you can place those kind of messages and send that information to analytics. And from there on, you gather that data, and for that data, you can determine how the app is being used. And this is just a simple example of a certain analytics that you could introduce. From there, you have I think about 250 different analytics types you could add and within your app. So there's a lot of data you could collect. If you want to do it, or if it's if your people, so if the crowd is willing to let you gather that intel, of course, is also debatable. But from a health perspective of the app, of course, you can to make sure that everything is running smoothly. Analytics, yes, is a step ahead. You can monitor. And gather information on people, or at least on phones, running your apps. I don't claim that it's directly a GDPR issue or something, but you need to be mindful of which kind of events you are adding, and what are you trying to achieve. So with App Center, you can do this, and this is of course very nice. But the main thing, which is also very nice, is that you could sideload these kind of apps onto devices. And for that, I will also show you, I just already uploaded an APK or an AAB, an Android application bundle in prior this session. And if I go there, then I have multiple options. I can download it, but hey, on the Mac, I don't need any APK. I want to have this on a device. So you can organize yourself to have certain groups, and within those groups, you can then set certain testers, and within the testers, you can then say, hey, I want to distribute a certain release to a certain test group, and they can or are allowed to sideload that app to do their tests. So this is ideal for user acceptance tests, for example, or other kinds of tests within the tester just wants to test on a specific physical device. Then you can. So when you it goes, you can do this on multiple ways. You can have a certain public link. I do not advise it, but you can do that and distribute that link for a certain period of time. But you could also do it via a QR code. So you now see a QR code. I don't hope you're all gonna install it, but you can try it. And I will do the same currently on my phone. And then just take a, let's say, Google Lens for instance. If you have an Android phone, that is. If you have a iOS, you could use the other camera app, and it will recognize a link. And if you click that link, of course, you get some intel on, hey, it's not safe to sideload the app and all those kind of things. And of course, you need to have a Microsoft account to be able to log into App Center. And one side note I want to give you guys before I go back to my presentation is that a main thing that goes wrong is that these devices are set on showing a desktop version of App Center. So make sure in your device, in your browser options, that you set it on the mobile way of. Because if you show just the desktop version of the app, you cannot click on the download or install button. It will not be visible. So that's something practical to take home with you guys. So I downloaded.
I guess that's a very nice way to wrap up the presentation, Arjan. I don't want to cut you off, but
So if there aren't any questions, please feel free to address them.
Yes, because I did have
currently
one
my
small
phone
question.
is downloading it, downloading the app. So in the meantime, if I have a result, then I will show it in a sec.
Yeah,
but this
no
is a nice way to keep control of who's getting the app.
Okay, so in the meantime, let me quickly ask one question, and then I would kindly ask you to check out the chat for any other questions that might have passed already. So the one question that I have is, I noticed that you were showing different emulators for iOS and for Android. But does that mean that the App Center provides those emulators, and do I need a certain OS? Like, can I only do the iOS emulator on a MacBook, or can I also do that from a Windows device?
Well, you can currently use some Macs in a virtual way, so that you could use a simulator. But there's a small difference. And the main difference is that we have the world of emulators and we have the world of simulators.
Mm-hmm.
And the devices simulated by Apple on their devices are simulations.
Okay.
I mean, they are not the same, not the byte by byte the same as the emulators. So if an app works on a simulator, it's not guaranteed that it will work on a physical device.
Okay, that makes
and
sense.
For an emulator, it is. And so that's a main difference. Android, of course, can do both. Can run easily on Windows and Mac. Simulators only work because they are distributed via Xcode on a Mac system. But there are ways to virtualize a Mac these days. I tend for real testing purpose, I tend to use physical devices because simulators aren't that reliant.
Well, that makes sense, and that also gives me a very good business case to talk to my manager and persuade the next purchase of a MacBook. So
exactly.
Thank you very much for.
Apple loves to have you on a Mac OS, right?
That's good to know. So thank you very much for presenting. Unfortunately, we have to go on and introduce our next speaker. So please hang around, answer some of the questions that might pop up in the chat. And once again, thanks and enjoy the rest of the evening.
Thank you.
Thank you, guys. Thanks for having me. And my maiden virgin, the maiden voyage I had these days. So yeah, thanks. Bye-bye.
Thank you. Bye-bye. So it is time for our next speaker. Do you want to introduce her?
Yeah, sure. So our next speaker is Marilag, and I hope I pronounce your name correctly. So please correct me if I made a mistake, because I find it very important to address people in the right manners. I kind of want to not steal away any from your presenter time. So if you want to go ahead and introduce yourself because it's part of the first slides, then let's go. Otherwise, I definitely want to give you a little bit of time to promote this awesome organization that you started this year, Marilag, to help those people that are a bit less fortunate or are like the Philippines, who really can use some sponsors to help them get to their technical goals and to make them great contributors to our community as well. So you might want to take this opportunity to promote it and ask bluntly for some sponsoring as well. So I would like to give you all the time and the floor. Thank you, Marilag.
Thank you very much. I'm really happy that you mentioned ulap.org. I hope I will have time to talk a little bit more about that. Otherwise, we have a great website where you can find everything. But yes, I'm not going to bluntly ask for partnerships and volunteers and sponsor. I'm just going to directly ask for it. But first, let me just share my screen so I can properly introduce myself. Hope everything works. All right. So my name is it's pronounced Marilag, and don't worry, it's a very unique name even for Filipino. So a lot of people don't know how to pronounce my name. And so yeah, thank you very much for inviting me here on Azure Thursday. I realize it's dinner time, so I'm gonna try my best not to make any of you lose your appetite. Just a little bit about myself. So I am a tech and social entrepreneur from Device. I'm from the Philippines, but I currently live here in Denmark for over a decade now. And as I mentioned, I'm a co-founder of ulap.org together with one of my friends, Michelle Tabirao. And we just started March. And the whole concept of ulap.org is that we find these kids right now in the Philippines, because that's our first target. These kids who are underrepresented, underprivileged, but really have passion for IT and really want to learn, and we want to kickstart with their career in cloud, and not just one cloud, but multi-cloud. So they get all the official training, paths, and certification from different cloud vendors. And now we're also getting a lot of partnership with online learning so that they can do self-paced training for free. It's great. So I hope you follow the development of wulup.org in my LinkedIn post or visit our website if you want to know more. So I'm really, really passionate about the community. But today I'm putting my technical hat. I've also been a developer since I was 70 years old, and I still love code. I don't know if it loves me. So I want to start my presentation with a little game, and it's called the Gossip Game. We played this a lot when we were kids, and the whole idea of the game is that the master of the game passes on a secret to the first person in a queue. So you form a queue, and then the first person pass the message on to the next and to the next until the message reaches the last person, who will then blurt out the message or the secret. And the team is able to say the correct secret, the message, wins the game. And the thing is, hardly anybody wins because you know how it is with messages if you pass it on from one person to another. That's why it's called the Gossip Game. And I really want to try to play it today, but unfortunately we don't have, we're not here physically. We can also use the chat because I'm guessing this is live stream, so there might be a little delay. But what I want to try to do, not sure it's going to work, is still play it. So I'm going to display a story, a short story from my deck here. And I'm going to remove it maybe after a couple of seconds and try to remember as much as you can from the story and try to write that on the comment section on chat or maybe tweet or something. Just tag me. And then later after my talk, I'm going to look at the messages and find the one who got the closest to the story. And then, of course, I'm going to check the timestamp. So let's try it out. And I'm going to give you a prize. So let's try it out. Here it goes. Please don't cheat. Don't make any screenshots. This is just for fun. This is the story. A little bit of tech facts that could potentially turn into tech gossip. All right, one more sec, and I am going to scroll further down. I wonder who won. We will find out later on. But if you've had challenge the remembering the bits and pieces and then you try to relate again, you're not alone. So apparently what we learned from this game is messages can be very tricky to handle. And let's examine a couple of reasons why that is. Maybe it's just about insufficient memory. I suffer the same fate. But no, they say that an average person actually can only keep about 4 items in its short-term memory within 30 seconds. I'm not sure even if I can keep as much, but it's just the way our memory goes. It's so hard to keep them in our short-term memory. Or maybe there's just way too much information. They also say that we can remember only about 7 words at a time. But if you remember the words person, woman, man, camera, TV, and repeat it over and over again, you could probably run for a president. You have the IQ for that. Other reasons: you're tired, you're sleepy, you're hungry, or you're just not paying attention. You're watching Squid Game or something else on Netflix while you're watching my talk. That's completely fine. But these are our limitations as human beings, and apparently machines are not so different from us, even though, of course, they're just a slightly, better than us. They're still susceptible with, making the same blunders. And sometimes the computer glitch, the machine glitch is so weird that you can't really understand what went wrong. It happened to me the other day, my own brain. So I made a sandwich, a peanut butter sandwich. I couldn't remember if I ate it or not. So the peanut butter was on the counter, the bread was gone, but there's nothing in my memory that said I ate the peanut butter sandwich. So we suffered that same glitch. So this talk is really all about how can we address these physical limitations of machines using message brokering and event-driven architecture using Azure services. So there's going to be a little bit of introduction to some of the concepts for those of you who's very still new to message brokering. and event read. So I'm going to have some demo, very simple, so that we can really break it down and understand the concept behind queues, service bus, and event grid. Nothing special. And then further on, we can talk a little bit about some architectural patterns and discuss a little bit some of the design pitfalls that we can watch out for if we're working with distributed applications. My demo is in C#, so if you're not a C# developer, it's fine. I think you should be able to follow the whole concept. It's not also a niche topic, as queues and all this is really old in Azure space, but I still feel like a lot of engineers encounter challenges picking the right tool when they're dealing with distributed applications. So they just get lost in the whole distributed dungeon. So distributed dungeon, according to Leslie Lamport, who is a winner of a Turing Award, he's done massive work around distributed dungeon. He's got a really good explanation about distributed systems for Cosmos DB. Find that on YouTube. And he said in this code, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Why are we talking about this? Because precisely all this messaging that we're learning right now is to solve the distributed problems. So if you've been a developer, network engineers, or you've just pretty much used software, you probably already encountered a very simple setup of most systems now with N-tier applications. So typically a web application would have the browser, you have a front end, you have a couple of services, backend services doing the logic, and a data. So it really looks sort of harmless, but it's not quite that harmless. Because if you think about it, what do you do if all of a sudden you have a surge of users? Or what if your user executes different commands on the front end and you have to process that sequentially? Or what if your service all of a sudden couldn't process the message it received because it is malformed? Or worst, what if your database just exploded? How do you handle this? So all of a sudden, this simple test system becomes much larger, or gives much larger test surface. So all of a sudden, we all have to think about the different pillars of good architecture, reliability, performance, security, operationability, maintainability, and cost at every point-to-point communication. So not just as a whole, but every time we cross boundaries, network boundaries, we need to consider this and, expand our test coverage so we avoid issues. But now let's really look at, for now, reliability and performance and how messaging can really help. So the way it works is that to be able to communicate with each other, you pass data. And two types of data for communication is message and events. So we're going to learn a little bit the difference between message and events because it's really important when choosing the right services. So what are messages? They're not, they may sound similar, but they're really not. So message is piece of data that indicates that something must happen. Remember, must happen. So if this is a producer, I can send a message to the receiver and the receiver must do some action over to that message. Message contains essential information so the receiver can execute that action. That action can be a command. For example, I need to change a state in my system. And these are very high valued message because if I do not complete this command or I receive an incorrect message, then something goes wrong with the system. The action is also maybe in charge of changing the state of the actual message. That means if I have processed that message, I can either complete it, or if something went wrong, I can put it in a dead letter, or I can defer it for later processing so that that receiver has a way to get back to the sender what to do with that message. Whereas events, if you look at events, the purpose of event is also a piece of data used for communication, but it already indicates that something has already happened. And an event may or may not trigger a reaction. So it's not necessary that a component that subscribed to that event has to do something. There's no contract between the producer and their subscriber. And event data typically also contains just a reference to a relevant entity that was changed. It doesn't have to contain every single piece of information. It could just be a reference. So for example, your event is triggered because a state has changed. Then your event data might contain the link to that entity so that you can query and see the current state of that entity. Also, you can, in your event data, you can also contain a reference for retrieving the actual data about the event, which is two very different things. The data about the event may contain this a reference to the state of the entity affected by that event, the time that event was triggered, which can be very different from the current state. So just something to think about. So if you really understand the difference with message and event and what is required by use case, it's much easier for you to decide which Azure services to use. So very simply put, for messaging, we have Azure Storage Queues and Service Bus. But for events, we have Event Grid, Event Hub, and you can also run other event streaming services on Azure like Kafka. We're not going to talk about Event Hub and Kafka today because these are more for streaming large events, large amount of events, for example, for IoT or logging. I want to focus on application development. So we're going to stick with this 3 different services for now. So let's have a quick look on Azure Queues. So if we go to my portal, I have already created the different resources. So this is my storage account, and under this you can find the queue. And here I already created queues. When you create queues, you just give it a name, easy as that. And how do we interact with these queues? What are the typical operation to queues? As I mentioned, you need to send a message and something must receive that message. So if you look at my little demo here, how that works, let me try to call this API. So what this does is it actually just splits this whole story into words, and each word is sent as a message to the queue. That's all. And then I have an Azure function triggered by that queue to display that message, just so I can illustrate what's happening. So if I call this, you can see my API is still processing. It's not done yet, but my receiver is already processing in its end some of the items and words. Now it's done. Now I got the data. So this is also, this illustrates one advantage of having brokers in between components. This is what you call temporal decoupling, meaning your producer can and receiver can process these messages at their own time. So producer can produce the message and the receiver can just react in its own time. They don't have to be in the same time. So that's temporal decoupling and one advantage. So Azure Queues are really very good for some of these simple scenarios, load balancing, load leveling. Load leveling is when you want to throttle how many requests can process by an instance of your service. For example, if you have Azure function and you don't really want to pay for auto scaling because it's not necessary, but you still want to control the amount of messages it receives, then you can use a queue. All right, so when I mean simple, it doesn't mean that you're only using it for small stuff. So there are some use cases where even for enterprises where you need Azure Queues. So just to summarize with Azure Queues, it helps with load balancing, temporal decoupling, and Azure Queues is also good for if you need to have a larger queue size. It supports up to 500 terabytes. It also supports at least once of sending messages, but take note, it's at least once, so it can be more than once. So your application needs to be able to handle duplicates. It also has server logs. So that's Azure Queue. But one thing you notice here, let me just put that up again, the data. So here you can see the words came, but in some of my examples in my tests, the words actually did not come in the same order as the story. So it got jumbled. Often in queues, it's possible to, it's often first in, first out, but not always. So if you really need to ensure first in, first out, you move to service bus. So let's look at the next demo. And I will show you how to implement a very, very simple first in, first out. But first, for those of you who's also new with Service Bus, I have also created one here and one that is on a standard tier because there are some, obviously some functionality that is only available for standard tier and premium tier. So this is a standard tier. As you can see, I can also create the topics. We'll talk about that later. But here you can also create a queue. Obviously, you can also do it automatically with, with your CI/CD and infrastructure code. You just want to show it on the portal. So if I create a queue here, well, now there are way more configuration that I need to understand here. And each of these configuration is important when you want to implement your use case. So for example, now I want to demonstrate how to do first in, first out. So you have to enable sessions. Sessions is basically you can tag messages under the same session, and the recipient of these messages makes sure that they receive or they send the messages and receive the messages in the correct order within that session. So if it's two different sessions, of course, there's a chance that you don't receive it in, first out mode. So how do we implement this very simply in Azure Function? So again, let me show a quick demo. So I have FIFO here. This thing does the exact same thing as this first story. I also parse it. It's probably not obvious what's happening here, but I can guarantee that this is in order.
Marilag,
Yeah.
sorry to interrupt, but can you zoom a bit because it's a bit unclear?
Yeah, sure. Let me. How about that?
Yeah, perfect.
Awesome.
Is it better?
Yeah.
Sorry. Okay. Yeah, I was wondering actually if. Yeah. Sorry for not asking right away. Okay.
No worries.
Is that better? So these are just the words, right? It's hard to see for my test, but just trust me that when I try to run this against Azure Storage, sometimes two words came in two different order, which makes the story that becomes a gossip. All right. So moving on, the first in, first out guarantee that. And if you look a little bit at my very simple code for sending messages to Service Bus, so I just use the typical .NET SDK to connect to the Service Bus with an endpoint. And with the SDK, you create a sender, and then you form your Service Bus message, and then you call send. And you can see here, I pass a session ID. In this case, what I did is, in my function, I just took the execution ID of the context and made that my session ID. So every word belongs to the same session because that's one call, and and then it gets sent. But the interesting part is in your receiver. So Service Bus trigger is also out of the box from Azure Function. You just give the name of your queue, the connection string here, which in this case is in the configuration. And there's something here that's quite more important. So you pass the session enabled. Yeah. Oh. Because now there we go. My my mouse don't work with resizing VS Code. So you need to explicitly put is session enabled to your trigger here to make sure that it processes the same session. So if you have multiple instances of the function, make sure that it routes to the same instance that gets a session. And you can also retrieve the session ID from the message. So I think if I just take this, which is also parameter, you can also find session ID, and you can do some logic around that. But basically, very simple, first in, first out. So what if I also want to do some sort of transactions? And so Service Bus supports what you call a transaction. And a transaction just simply means that if you want to carry out several series of operations against your services or Service Bus, against your messages, you can make sure that all these operations succeed before you commit the transaction. If it doesn't succeed or one of the operations fail, then you can roll back everything. So that is also supported. In my demo, you probably won't be able to see the big difference in a transaction, but you can see here from the code, if I go like here, send message transaction. So all you have to do is enclose the call in a transaction scope. And every time you call send message sync, it's not completely committed until you call TS complete. So you can also abort the transaction, typical with when you're doing atomic operations against your database. You may or may not pass session ID. That's not required. I just wanted to make sure that they're also in order. So a lot of these advanced features for Service Bus will really help you satisfy very specific use cases in your application. Because imagine if, let's say in a shopping cart that you don't want to deliver the goods until you make sure that, the credit card, the payment has been completed. So we don't want to jumble things around. So that's Service Bus. And so now you ask, what if right now you have seen that I have one function for, let me just close this so I don't get confused. I have one function for triggering one queue, one service queue. But what if I want several functions to receive the same messages? Then we can implement topics and subscriptions. So it's a little bit different. So if we go back to the portal here and look at the topics, so here you can also create a topic. So the idea of a topic is that you can send a message to the topic and then the topic will forward it to all its subscribers. How does that work? So if you see, if I open this up, I can find my subscribers here. I don't know why that was not scrolling. So yeah, so I have 3 subscribers here. And if I open that, so a subscriber is essentially actually just another queue, a sub queue. So your subscriber is subscribing to a specific queue within the topic. So you can do fan out. So you can also have different configuration for this specific subscriptions. For example, in subscription 1, I want to do dead lettering and all these things. But I don't want to do that with subscription 2. So you can be very specific with your configuration. And how does this work in code? So for the sender, it's not different. It's just sending to the topic. So you pass the queue name as the topic here, for example, juicy gossips, and the whole code is basically the same. But for your receiver, that's the same. You can also have a service bus trigger for your Azure function. You put the topic name here, and you put the subscription name. This will be the exact subscription name you have created on your service bus. So this now 2 functions will be triggered if I send a message. So let's see. There's my Thunder client. So let me try to post something. Same, a little shorter message here. And you should be able to see. Let me just scroll down here. So you can see that I have received for this function and also received for that function. So really, very, very simple. So what if, something went wrong? So let's say in the second, another subscription wasn't able to process the message and it needs to handle that issue. So Service Bus also support dead lettering. That means that, when something goes wrong, you can dead letter a message, put that in a dead letter queue. It's also another sub queue. And the thing is, with dead lettering, what happens is that the message stays in the dead letter as long as there's no handler. So it has to wait for a handler to pick it up and then also complete it. So if there are no handlers, there are no receivers from the dead, no function listening to the dead letter queue, then it's just going to stay there. There's no expiration. So if we look at the code for the dead letters, also again, very simple. So I have the receiver here. And let me just uncomment this code. Oops. So one thing to note here is that this one is the same. It's just a subscription tree. But when I receive it, I put it in the dead letter. So, your message receiver as in operation for that letter. And then I have another function that listens for that same topic, but instead of my subscription, you put the path of your sub queue. In this case, this is $dead letter queue. So $dead letter queue is something that is system defined. It's not something I invented. So you just put that dead letter queue and it will receive the messages from the dead letter queue, and then it can also complete it. So quick demo on that. Let me try to trigger that again. See here, you can see some of the message going to the dead letter alert. So really simple way to interact with Service Bus. Let me just go back to my slide here. And we've done dead lettering. So I just want to summarize the stuff that you can do with Service Bus. It's really built for enterprise messaging services. It can guarantee, I didn't show this, but it can guarantee at most once. So it can have duplicate detection built in, unlike Azure Storage. But the downside is it has a smaller queue size. So it only supports about 1 gigabyte to 80 gigabyte of queue size. And also there is a limit on the number of queues that you can create per Service Bus namespace. I think that's around 10,000. And if you need more, I think you can contact support and request. I don't know how that works. I haven't tried creating more than 10,000 queues yet. All right, so I've discussed that lettering and all forwarding. So now let's go back to our original discussion about messages and events. So what do we do with events now? Now something has happened, the state has changed, and I just need to broadcast that without really caring about what the consumer will do with it. So one service in Azure that I can use is Event Grid, which is built for pub/sub notification. It's a push notification system. Actually, Event Grid is what Azure services use as event source so that it can broadcast almost virtually all the activities within the Azure infrastructure so that other Azure services can react or listen to these events, or your application, or if you're doing automation. Event Grid is what you normally would subscribe to. But you can also use Event Grid if you want to just, publish your application's events. We've done that in some customer project, and that works. It's also serverless. It's low cost. There are other good features about it. It does automatic retry for 24 hours with automatic exponential backup. I don't think you can really do much about this in configuration, but you can also do dead lettering. So dead lettering in Event Grid is not on by default. You have to turn it on, and then you have to specify a storage blob. So the difference, you can see that in normal Service Bus queue, the dead letter is just another queue that you can subscribe to listen to. So that's much easier processing. Whereas for the Event Grid, and then you have to read the blob. And what happens if the blob is not available, the storage blob? Well, then the event goes to limbo and you will miss it. Probably won't happen, but it could potentially happen. So quick way of interacting with the Event Grid service. So again, the operations for sending and receiving events. It's a little bit different than what I did before. If I go to my demo here and look at what I want to post. So if I just look at the body, I actually have a schema that I designed so that I can comply with the schema that the Azure Event Grid expects. This is not the schema. Azure Event Grid has another schema. I just sort of abstracted that away. So here I just need, as a minimum, you need an event type, which is a string that describes what the event is about, in this case, message created. And then you can have a dynamic object for your data. And typically, as I mentioned, you can put a reference to some sort of a location like pretty much like a location header that you can call to do query about the specific entity that the event is all about. So something around that. So to make it very simple, I just use these three properties. And what I do is if I post here, I actually don't have, so nothing happens, it's just 200. I don't have a listener right now in Azure function, but you certainly can subscribe to event grid. But the thing is, event grid is push notification. I can't do it via local host here because I need to set it up in event grid. But let's have a look at the internals of event grid. So it's looking like a typical queue, but it really isn't. So I can also create subscription on the event grid, like you saw in topics. This is an event grid topic, so it's similar to the service bus topics. But see the difference here? There are a couple of notable differences. For example, I can add an event type. That means I can filter by the event type that I want to subscribe to. Well, that's actually also supported in service bus topics. You can also do very advanced filtering so that your subscribers can only get relevant messages. So you can do that here. So for example, the one I created, this message created, something like that. So you can put it here, type that here. And Event Grid supports several destinations within the Azure space. So you can connect to function, connect to queues as well. So you can do the whole cycle. In one of our applications, we actually use webhook. So the Event Grid calls our proxy, and then the proxy does the whole security and between Event Grid and our system, because it needs to do message exchange to make sure that the Event Grid is calling the correct endpoint before our proxy hands it over to the webhook. So there's whole funny magic we did there, but it's really quite interesting. But you can, the main point is that you can use webhook. And if what I did here is I use, just to illustrate, a storage account as a destination. So if I look at my storage account, I have a queue here. Well, I just also received the message that I posted from today. I think it's this one. And you can inspect the message here. So if your function, if it's an Azure function, for example, you are going to receive this as an array of messages. So you can just deserialize that into your object if you know the format of the event data that you expect to do, and then do some logic around. Right, so that is Event Grid. I can see I'm almost running out of time. I have a couple of minutes, so I'm just going to speed through this. There are a lot of questions, and I'm sure you have questions about the difference between queue, service bus, Event Grid. There's a good link here that really illustrates how comprehensive the differences are. And I can understand it could be very tricky to really pinpoint the correct service, but just do the homework, talk with the architecture team, talk with the developers, because you really need to do cross-checking of everything that you need, understand your use case, understand your limitations as well with your infrastructure. We also actually experienced where we implemented Event Grid, where afterwards we learned that we should have actually implemented service bus. So those are some of the things that you can encounter. So I have a little, maybe just to illustrate how we can put it all together in a real world scenario. So I have a diagram here of not a whole system, but just a subset of a system that we were working on. I can't show the code or the application, but I can, because it's a customer application, but I can share with you some of the architectural decisions that we made. So the whole system it's a large system for self-service portal for cloud engineers in an enterprise. And this design implements just one of the workflow for onboarding new digital products. And when you do that, there's a bunch of things that needs to happen. And for example, you can create the product and then do a lot of configuration along the way. So from a technical perspective, it's not so different from just implementing, any workflow over handling lifecycle of any entity. So let's start with, we have a static web apps as our front end. I'm sure you're all looking forward to John Papa's talk about static web apps. So we also use that in this application. So we start with a user, and then it triggers an orchestration. And since it's a long-running process that can possibly span a couple of days due to an approval, we implemented it as a durable function. So then, so the orchestration triggers the first activity, which is essentially creating the entity database. Again, another point-to-point thing that can cause us some issue. We need to be aware. So, and then it triggers the approval, which also has an expiration. So if it expires, the whole orchestration stops. And then after the approval, once it's approved, then these are the subset of things that can happen. For example, we start creating all the relevant AD groups in Azure Active Directory for the product team. We deploy or provision subscriptions, resource groups, etc. With the template against Azure API. And we create teams, product teams, assign them to groups, assign those groups role-based access control over the Azure resources. So all of this can take time. So it's just moving forward. And then towards the end, maybe we need to update the entities. So let's examine a few of the architectural points here. We put a queue between the web app and the durable orchestrator to make sure that we do load balancing or load leveling. And actually, each activity that you see here, we implement as commands, command handler, if you're familiar a little bit with the CQRS. And so after this command has completed, we trigger an internal message. So we're also, when the command succeeds, it also publishes an internal event captured, by an internal handler. So this is using the mediator pattern. So the internal handler will notify the next command if it's time to be executed. So that's what it's doing. So the notifier will then trigger the next chain of commands and so on and so forth. So if you have commands that needs to run in parallel, then of course it's a notification. Then all the commands that implements or that will handle the same event will simply run. If an error occurs somewhere in the process, we also have a handler for errors, and we try to determine where in the process the error happened and what kind of error, because then we can decide whether we want to retry or we want to roll back or we want to move forward. It depends really on the scenario. So if it's a fatal error, we end the orchestration. But if you notice also, we have queues in some of these activities because we actually also expose them as APIs so that we're able to call these APIs directly in order to recover from the process. But if things are successful, the durable orchestration fires the last internal event, which say, hey, I'm good, I'm completed. And then the handler for that event then posts something on the event grid. So other subsystems in the different bounded context in different domain can react. But this process doesn't really care what happens here from this point on. So that is one of the implementation that we did. We're still learning a lot. We're still trying to optimize this. So if you have ideas, ping me, let me know if you think this is totally nonsense. Some of the design pitfalls that we really need to remember implementing this is, of course, we always have to remember all the architectural pillars also with our own queues. The performance of our queues, the reliability, how, you need to do also or think about the geo replications and redundancies of your queues because you don't want to lose your messages. So understand the concept of all your availability zones when you're deploying the storage or service bus. Of course, the cost, operationability, and security. So who can really subscribe to messages or send messages, and make sure that you understand the security requirements for that. You have to avoid building queues of queues, which means like a spaghetti list of queues. So want to try to limit the system boundaries where humans can still track them. Otherwise, if it's a really large system, I've seen in one very large enterprise we worked with that they really have a centralized department that takes care of the catalogs of all their APIs and all their event sources and who subscribe to what. But you need the tooling for that. And of course, some sort of governance way of thinking. Another thing that's very important is distributed tracing. You can use App Insight. There are a couple of tutorials that will tell you how to see all these message flows end to end. But the whole concept basically is, understanding from the very beginning that you can use correlation, or you have to correlate every single step in your distributed application to make sure that you can trace them and look at application insight, for example, by an event ID or operation ID or execution ID, and see the whole flow of events. So I've mentioned security. And other things I want to share, I put the link here. I don't have time to explain that. Is, in my dev team's toolpack so that we understand really the end-to-end of implementing event-driven architecture. We start from the design process, which is event modeling. This is our diagramming to how to illustrate and model our events. And also within our internal code, how we create our classes, our commands, our handlers with the thinking that this is event-driven. So lastly, just want to do a recap. Now you know the differences between messages and events, when to use queues, service bus, event grids, and hubs. I suggest you really learn how to model your events and try to have a large, coverage for tests to handle all the known and especially the unknown issues that can frequently happen in distributed applications. Design your tracing strategy up front, and event-driven architecture really begins with your team's mindset. So that ends my talk for the day. Thank you for your time. You can reach me on Twitter, and you can also get everything here on my GitHub account.
Awesome.
Thank you.
Thank you very much, Marilag, for this very clear explanation of making sure that even I understand the differences between the queues and the service bus, because that sometimes is very confusing for me from an operational background. So I really loved how you explained it, and even got me convinced to make sure that I'm switching or promoting service bus usage even better. And basically the only question that I had was that I wanted to make sure that I knew how to reach your code. So thank you for already answering that by reverting us to your GitHub repositories. So I'll definitely check those out. And if you still want to promote ulab.org, please do so in the chat. Check if there are any more questions. But I think with your awesome recap, that, all I can say is that I'm in awe of your presentation, and I would love to see more and talk more with you. But yeah, we also have another presenter in the queue
actually
already.
Really looking forward to that. I'm a big fan of John Papa. I learned a lot from him in our early days building front end. So great community effort here. Thank you for your time as well. Thank you for having me.
Thank you for joining.
Thank you very much.
Yeah, let's bring on John Papa.
Bye-bye.
Bye.
Good evening, John, or good day.
Good morning.
Yeah, whatever time it is, right?
Yes.
Hey,
How are
thanks
you?
for having me here.
Yeah, thanks for being here. How are you doing?
I'm doing great. I'm living in Florida. It's sunny. I get to go outside, and this day and age, that makes me happy.
Good to hear, good to hear. So you have a question for John, right?
Yes, so I was looking at your LinkedIn profile, and of course I was already in awe with your track record of the different jobs you had. But I have to admit, I kind of got sidetracked when I saw Disney. Because, I can tell you, I'm a huge Disney fan. And the other thing that really triggered my question that I want to ask is that I saw that you are a great storyteller as well. So for me to learn to do storytelling, I attended different Toastmasters clubs. And I know that's even a well-known institute in the US. So it will probably not surprise you that one of my favorite topics within Toastmasters is the impromptu speaking. And I got the honor to prepare some impromptu speaking questions in my past in Toastmasters. And my most favorite one was to basically surprise the speakers by asking them which Disney princess do you want to be? And please explain to me why. So I have to admit that I kind of persuaded Sjoukje to give me some airtime to ask you that question.
That's awesome. Actually, I love asking that question myself. When I worked for Disney, quick side story is one of the questions I would ask people during interviews is, what's your favorite Disney character? Overall Disney character. And I thought it was fascinating how, this is just to break the ice, it was fascinating how some people would come back with Tom and Jerry or Bugs Bunny or people that are totally not Disney, which I thought was always interesting. I'm like, you're applying for a job at Disney and you're telling me you're not Disney.
Yeah, nerves.
Yeah, I think princess-wise,
nerves for the interview. Yeah.
I think, I have 3 daughters and they all like different Disney princesses as their own. One of my daughters loves Ariel. Another one, honestly, Snow White's probably her favorite princess, but Stitch is her favorite character. And then the other one, it is definitely Rapunzel. And for me, my favorite, it might be Merida from Brave, although it changes a lot. She's just so independent and so awesome and kind of just does everything her own way. Although I like Raya a lot too. So I like the strength in the characters.
Well, that's great to hear, but I didn't want to distract you from your presentation.
Let's talk about Disney. Let's do Disney instead. Come on.
Yeah, that would definitely get everyone excited, but I'm pretty sure that you have an awesome story to share as well. So I will not keep you from that or keep the audience from another great story. So I'll just let you get started and just think about some more Disney princesses to go over in the questionnaire afterwards.
I think I will, and maybe we can ask folks in the chat or the questions, to tell us who your favorite Disney character is, or maybe you can spot some Disney-related things in my office behind me during the conversation today.
Nice. So I like that challenge. Yeah.
So you got me smiling. That's a good thing. So I'm really happy to be here for Azure Thursday because one of the things I love talking about lately is Azure Static Web Apps. And to tell you why I love this so much, it's because my background as an engineer and architect, I find that this solves a problem I knew I had. Far too often in the tech industry, I think we see people coming out with solutions and they tell you how amazing something is, but they don't necessarily tell you what problem it's solving. Or if they do, you're like, that's great, but I never had that problem in the first place. So today, I'm going to talk to you about how I feel like this could solve a lot of the things that you're already struggling with today. So to begin, we'll start with a little story. Why not? And this story is all about modern day and age. And imagine, you're a developer and you're building an application. And the most fun part for you is probably putting the application together. Maybe you choose React or Vue or Svelte or Angular. Could be anything. You're building the application, you got the CSS working, things are looking and feeling good to you. That's the fun part. Now your boss tells you, we have to deploy this. Well, okay, you just had a lot of fun writing the code. Like developers like to develop. I'm with you, I feel that. But when you deploy it and you want to put a production scale app, maybe for millions of users to use, you now have to think about, how do I do source control? How do I push this up to something like GitHub? What's my branching strategy? How do I manage CI and CD, continuous integration and continuous deployment? Do I have to connect any wires up to make all this work? Because I want to make sure when I make changes, they get out to my production sites. What about my APIs? Most of my applications have data, so I've got to have a back end somewhere that I can connect to. Now, once I've got those APIs running, do they scale? And once you introduce a back end that's different from your front end, maybe your front end's running on a CDN, Maybe your backend's running on serverless functions. You now have to route your requests from the front end to the API. And I know what you're all thinking, cores. Oh, how do we handle cores up there now? So now we've got to manage making sure we've got that all set up to route those requests, or maybe API management. Okay, we all have to worry about security at some point, so we need SSL certificates, which are always fun to go obtain and then connect to our sites, make sure we're always secure. And then maybe you want a custom domain. We don't want some random IP or URL to be up there. We want our address to be something like shopathome.dev, which you can try out for our demo. How about authentication? You are the person that you say you are. When you log in, I want to know that you are John, or you are Sally, or you are Mary. I want to know that you are who you say you are. So I need authentication, and of course, I also need to know authorization. What can Mary or Sally do when you log into the application? So now I have roles. Security isn't just SSL. It's also making sure we got authentication and authorization. We also need global scale. We're doing this across the world right now. You could be in Europe, in Asia, in North America. You could be anywhere in the world. So I want to make sure I've got my points of presence set up. What does that mean? It means that somebody in India can hit our website and they're hitting the closest, fastest location to get to there, to get to the application. CDNs, right? Oh my gosh. You know, I just took the fun out of developing, right? We're just like, we want to build this website. We want to write our code. I want to use my React or Angular, and I want to put things together. Now my boss is really dragging me down by saying, I have to make sure that this is really a solid, fully architected solution. And you can do this in any cloud environment, but you just want to build a web app. So what choices do you have? Well, it gets worse, right? Because you can choose things like Angular or React or Svelte or Vue or whatever your favorite framework is. You want to make sure that any of those tools you use will work in that architecture and environment. Now, all of these tools today have changed the way the web works. Years ago, we used to be able to drop a script into a page and it was a web app and you run and you're done. There was no build process. But today, all these applications, we run commands like npm run build. Why does this matter? Think about what happens when you build your app locally. You take your application, you run npm run build locally on your machine, it generates the code, your assets, and then you launch it locally. Well, if you push the code up into GitHub and then launch it into the cloud, say to Azure, who's building the code? You can't just take the source code and push it to the cloud, or can you? So we run npm run build, right? And then something spins inside of our computer and it makes sure it's got the right assets and it outputs the three basic pieces of a website: HTML, JavaScript, and CSS. All browsers are going to be able to read these. And then it lights up our web application. That's what we really want. We want something to build that and launch it to the site. Now, what I'm going to tell you is today, Azure Static Web Apps will do a lot of this for you and make all that monotony that I just talked about really go away, so you can just focus on the part that you love, which is writing the code. So we're going to quickly deploy a web app with scale and security and a lot of other fun big words. And my name's John Papa. I work for Microsoft in the Student and Education Cloud Advocacy team. And I want to show you how easy it is to use static web apps with your application. So at the core, static web apps lets you build and host your web apps. And the build piece is huge. Of course, we want it to host them. But remember, we talked about that run build step. npm run build. It's got to happen somewhere. So where are we going to do that? It's going to handle that for us. It's going to make authentication and authorization relatively easy for us to include in our application. And we'll see that too. We can also optionally include APIs powered by Azure Functions. Now, if you want to use APIs from another service or your own backend, you can also do that. But if you choose Azure Functions, it'll automatically connect them for you without having to worry about setting up cores to go across the proxy. And today you can choose whether you want to use GitHub or Azure DevOps for your CI/CD provider for Azure Static Web Apps. We'll be using GitHub here in the demo today. But let's take a look at a picture on how this works. You make some code changes, the fun part. I make some code changes, things get running, I'm feeling good about it locally. I then push that up to my source control, let's say GitHub or Azure DevOps. And then that goes through its build process, the continuous delivery. At that point, it's going to build the code up in Azure for us, and it's going to generate the static content, our HTML, images, JavaScript, CSS, fonts, for example. And optionally, if we have any functions, it'll push those up there. And collectively, those built assets get published to Azure at scale, and that is Azure Static Web Apps. The only thing you have to do is write your code and push to GitHub. Write your code, push to GitHub. That's it. Now, one side note here, what I think is really interesting here is when you run it locally on your machine, if you want to test it on your local machine, just like it's going to work inside of Azure, you can use something called the Static Web Apps CLI. The Static Web Apps CLI is a great tool that comes with Static Web Apps, and you can use it through Visual Studio Code if you'd like to in the terminal. And what it lets you do is it lets you launch your web app and your API and your authentication authorization requests, and it emulates like it's running inside of Azure. Why is this important? Because remember, when you're running a web app and your authentication, you don't have the authentication server on your local machine. So if you want to emulate authentication and authorization, you need something to help you with that. So it'll let you emulate it locally, so what you run locally when it works will also run in the cloud. Another way to put it is, works on my machine, works in the cloud. So let's take a look at how this works through a demo. I've got a multi-part demo I want to show you, and here's what we're going to look at. We're going to look at an application, writing with some code, and then we're going to take that code and we're going to connect an API to it to get our data. We'll use the shop at home example where we get a list of products like strawberries. And then we're going to set up authentication and authorization for the application. Now it's going to do a bunch of things for us. And let's review a lot of the stuff that's going to happen under the covers. All we care about is writing the code for the app. Under the covers, though, I'll peel back so you can see what's in there. Part of what's in there is we'll be using GitHub for our source control. And then we're also going to get, out of the box, we're going to get scale. This is going to go across to multiple points of presence on the web or CDNs. We're going to automatically get our custom domain that we can set up with our application. As long as you purchase a domain, you can establish it. We're going to get Azure Functions. We're going to get routing between the Functions app automatically with the application. So it's going to connect those two for us with a proxy, reverse proxy. And it's also going to set up CI/CD for us out of the box. And then we're also going to look at authentication and authorization in the app. So let's get out of some slides here. And let's go look at the running app first. So I'm going to show you a version of the app, just because we get to pick what we want, running in Vue, Angular, React, or Svelte. I've color-coded these to the base colors of each of the application, but there are 4 versions of this application running in 4 different Azure Static Web Apps accounts. And just to show you that it doesn't matter if you're using Svelte, React, Angular, or Vue, or whatever your favorite flavor is. On the demos here, I'll be using Svelte, and we'll see why in just a moment. But in each of these applications, you've got a list of products, and we can go look at the list from the menu. Here's the list that we have. We can also look at a list of discounts that we can get. And on the list of products, we can also edit those products if we want to. Notice we can also log in and log out. So if I bring this one front and center, I can click on log out from GitHub. Now when I'm logged out, notice the list and the discounts say unauthorized. When I log back in through GitHub, which I already authenticated, so now it just says welcome John from GitHub. Now we can go back and see the different lists and discounts. So we can see we've got security, both through authorization and authentication. You'll also notice the URLs in each of these windows. They're all using custom domains. I purchased the shop@home.dev domain. I think it was like 10 bucks. And with that domain, I basically set up that www is the Svelte version. React.shop@home.dev is the React version. Angular.shop@home.dev is the Angular version, and Vue.shop@home.dev is the Vue version. And all these are perfectly accessible where you can reach those right where you are while watching this. Okay, so let's take a look at the code in the application for a minute. And all this is available up on GitHub. And I'll give you the links at the end of the presentation. But if you're anxious and want to get there quickly, from any of these web applications, if you click on the Code in GitHub button, it'll actually open up GitHub in your browser for you to point you at the code, which is also right here. So back to the code example. What we've got here is a monorepo. Monorepo, for those of you not familiar, is exactly what it sounds like. It's a repo that's one repo, but what that means is it's got multiple applications in it. In this case, I'll zoom in a bit and we can look at the left. It has a folder for the Angular app. It's got a folder for the React app, Svelte, and Vue. So all four applications are in this one repo. Why do that? Well, one thing is an ease of use. I can build and test all these applications at one time. Also, there's a lot of similarities. I built the same app in 4 technologies, so all the similarities, I get to see them in one place. And then probably the most technical reason is that they all share exactly the same API, the same back end. So I have one API folder to go get my discounts and my products. And that's written with Azure Functions. And that's in the same project here in the monorepo with Angular, React, Svelte, and Vue. So all those are set up for us to succeed. Now, if we look at the Svelte application, we can see inside of here, there's our source folder. And inside of our source folder, we've got our products in our store and our models. We've got our main homepage here. It says home. And we'll get rid of that. We can see here it says manage your shopping list, become a preferred customer, gain access if you'd like to. If we look at this side by side with the Svelte version of the app, put it on the right and the left here. I'll zoom in a little bit. We can see it says manage your shopping list over here and log in to start enjoying your benefits. What we can do is we could change this message to something else. So maybe what we want to do is right above that, let's go ahead and create an H3 and we'll say welcome Azure Thursday. Just like that. Now, obviously it's not running on the public web yet, but we just made a change and we want to push this up to the cloud. So what we can do is we could automatically just see how this works. I make my code changes and we're just going to say having fun. I'm going to commit that change. I'm going to synchronize it through VS Code. And then it's synchronizing. Now what's happening in the background now as it goes up to GitHub is it's building the application and then it's going to deploy it to the web. So let's take a look at what's happening here. On the right again, we've got Shop at Home. If I refresh, you're still not going to see the Azure Thursday quite yet. It has to build and redeploy. But let's take a closer look at what's happening. If we go up to GitHub directly, and I go over to Actions, you're going to see right there at the top, it says having fun, and it's spinning with a yellow circle. That is the having fun commit that I just made 26 seconds ago, and in progress, it's rebuilding that application so it can automatically deploy it. Now, a couple other things here. Let's say you didn't know that you could go there directly to the Actions tab. If we go back to VS Code, there is an Azure Static Web Apps extension that you can get to from the A over here. You can see mine's right there. Let's say you don't have it yet. What you can do is click on these 4 squares. You can type in Azure Static Web Apps, and it will find for you the Azure Static Web Apps extension right here. The extension is in preview, but the product is not. So the extension is a bunch of tools that we can use. I've already installed mine. And then through that extension, you can see I've got one called Shop at Home that I created. This is the Azure Static Web App. And I can do is I can right click and I can choose browse the site, or I can say go ahead and open it in the portal. I can clone the repository. There's a bunch of things I can do right from here. And you'll see the production site is going to main. If I click on the action, you'll see the having fun is right here. And you'll notice it's got a gray or whitish circle saying it's running. And what we could do is we could right click, we can go view the properties. We can also go look at the steps right here at the action log, or we can go directly to the browser and watch it run. Now this has been running for about 2 minutes and it says green over on the left now. That means it's done. It took 2 minutes and 2 seconds. Let's click on it. And before we do that, let's see if it works. We'll go to the right-hand side. We refresh, and you can see Welcome Azure Thursday. And if you refresh your browser, you should see that as well, as long as there's no caching. Now, over here, it said it was successful, but if we click on that, we can see the build and deploy job. And under the build and deploy, which took about 1 minute and 6 seconds, if we scroll down, you see some interesting messages. So Azure Static Web Apps utilizes this thing called Oryx. It's an internal tool at Microsoft that you can use, that you can learn more about here, to basically build the app. Let's step back for a minute. Remember that we were talking about how we just want to create our code, develop our application, but somebody needs to run npm run build. That somebody is being run through this action on GitHub. So here it's setting up Node on the machine. It's using this Node version and npm. It's going to run npm install on my package file. It's installing everything it needs, which there's a lot of stuff in there. Took 24 seconds, nice to see. And then it keeps running through. It's going to run npm install production. And then down below in the green area, you're going to see a couple interesting pieces. Down here, finished uploading. So it put the built assets into an artifact and then uploaded that to Azure at this URL. This URL called Purple Pond, a bunch of numbers, azurestaticapps.net. If I click on that, you'll see the same application on the left and right. Now notice this one's the big long URL and this one is the custom URL. We'll take a look at how that works in a moment. Once this build works, everything gets pushed up to Azure. But how did this ever get set up? That's really the question, right? So when we have a new application, let me zoom out a little bit. If we want to set up a new place to deploy this, what we can do is we could just click on a button up here in the Azure Static Web App extension. It says Create Static Web App. And once I do that, I can name it something. Let's just call this Azure Thursday Shop at Home. And it's going to ask me where to deploy it. Now you might be wondering, well, wait a minute, why is it asking me where to deploy it if this is deployed everywhere around the world? Well, it is. It's deployed at multiple points of presence around the world, but there's going to be certain aspects of this that will only run in one region. And I'll show you what those aspects are in a moment. They're actually really important for staging environments. So I'm going to just mention East US 2. I can then pick either a custom framework at the bottom, or I can pick one of these pre-built frameworks because we happen to know a lot about Angular, React, and Svelte apps. I'm going to choose custom just so you can see the step-by-step pieces. It's going to ask me some questions like, where is your app code? Remember, in my app, everything's inside of a folder called Svelte app, or Angular app, or React app. So I'm telling it here, yeah, it's in this folder called Svelte app. And then it's going to ask, where is the location of your build output relative to your app's location? In a Svelte application, there's a public folder. That's where it puts all the built assets. In React apps or Vue apps, it could put them in a dist folder. In an Angular app, it could put it in dist/name of the app. So it gives you the opportunity here to change where's the location of the code. This is important so it knows what to push to Azure. And then once you do that, it's going to go ahead and generate the new application and push it up into Azure and set up a new static web app. Now we've already got one. I just created a brand new one as well. But we're going to use the shop at home one. But you can see down here, we can also go check these out up at the web and see the actions running. If I click on that, let me show you what's happening. You can see that there's a new CI process running for a new static web app that we have. I'm going to cancel that, which we can cancel on the right, just because we don't need that specific one to run right now. All right. And if you ever want to delete one, you can. Like over here, we can right click it. You can delete Azure Thursday Shop at Home. And it's going to tell us down below that it's going to go through and delete this because what it created was a place to put all the files up in storage in Azure. It created a way to connect the backend functions, if any existed, to that storage. It creates a way for them to connect the backend to the front end. So a bunch of Azure services are getting created for you in the backend, but you didn't have to know which ones to create or how to connect them. It just puts them all together for you. Cool. So I mentioned something about how we check this out and how we can configure it for the custom URL. Let's take a closer look at that. Inside of here, in the extension, we've got Shop at Home, and I see production. We can see a bunch of other options like application settings. So we can see do we have any environment variables that we want to change or set. Here I have one that I happen to create for application insights, so I can instrument my application too. And then I can click on this button here if I want to show visibility of the key or not. I can also see if I have Azure functions running for this particular app. And this one I do. I've got 5 different functions to get the discounts and then full CRUD for products. And then I've got different GitHub configurations that I can check here. You can notice that I've got 4. You might wonder why I've got 4. Well, that's because in the same repo, I've got React, Angular, Vue, and Svelte down here. And the GitHub configuration is the 3 main questions we got asked. Where is your application, Svelte app? Where is the artifacts you're building, public? And then it didn't ask me this before, but I happen to set it. This is the optional piece of where's your API. Mine's in an API folder. So we can look at all that from here, but what if we go right to the portal, which you can do by right-clicking and choose, right here, where is it? I always forget which node it is. There we go. At the top node, Shop at Home, you can choose Open in Portal. And I've already got it open, so let's go ahead and look at that. Got to find the right window again. Put this one over there so we can see it side by side. There we go. So you got VS Code on the left, and we've got the portal on the right. And in this portal, we see an overview of Shop at Home. It shows us the URL without the custom domain, Purple Pond, but I bought shopathome.dev. So what I want to do is go to custom domains, and in here, what you do is you get 3 domains that you can configure. One out of the box is this Purple Pond. They make up a name for you, and that's the name of the URL. That's the one that comes out of the box. Well, I wanted to have www.shopathome.dev and svelte.shopathome.dev to work for me. So when I purchased shopathome.dev, what I did is I added both of these by clicking the add button to add the custom domain. Now you only get 3, which is why the add button's not there anymore, but all you have to do is buy the custom domain, click add, type the name of the domain in, and then it tells you, here's a key that you have to add to your DNS. So whoever your DNS provider is, where you bought your URL, for example, you want to go to them and put that key in there so it can point your DNS back to Azure and run your site. They say 24 to 48 hours for DNS changes. In my experience, I usually get pretty lucky, and it's usually within an hour, which is nice. For me, I've already set up shopathome.dev. Now, you might be wondering why I set svelte.shopathome.dev up. Well, that's because the main app is running on Svelte at Shop at Home. But let's say I go back, you'll notice I've got a version of it running for React. So I click on Shop at Home-React, and I go to Custom Domains. You'll see this one is running at a different URL called Brave Desert. And that's why I have this subdomain of react.shopathome.dev, and it's pointing to a different URL, which I could probably copy that, open a tab, paste it, and there you go. And here, because I only have 2 being used, I could click the add button. I could type in the domain, so I could say mydomain.com or spell it wrong. And then after you hit the next button, it'll verify that you have the domain. So let's say I put shopathome.dev. I could say foo, like that. Once I hit next, it's then going to tell you, okay, there's your domain name. Go ahead and copy the CNAME and add it to your DNS. And then once you do that, you can click add here, and it'll automatically go look for it. And it takes anywhere from a half minute to a minute to verify that you actually have that set up. And then it'll automatically ask the DNS to propagate. And I didn't set that up yet for foo, obviously, so I'm going to cancel that one. So that's how you set up custom domains with this. Now, if you've got a function like I do in these app folders right here in the API, you can see I've got functions like go get my products. So if I got a simple set of code here that says go get my products from this data provider, it's an async function, and it returns them if they work, and if it doesn't, returns a 500. All this automatically gets connected to the application. So my app, I just have to call the back end, which is shopathome.dev/API by default. So in my application, all my back end calls just get pointed to that. Now let's say I wanted to make a change, but I didn't want it to show up. right here. Like we said, welcome Azure Thursday. Let's say it's not really Azure Thursday. Let's say it's Azure Friday. So what I could do is I could go over to my code and we can reopen the page that I did this on. And here it was welcome Azure Thursday. And actually, let's just change it to goodbye Azure Thursday. Why not? Let's say I don't want this to go to production. I'm making a change, but I want to see it actually run first or get it ready to run first before I actually go live with it. So I want to do is I want to make this change, but not quite to prod. So what I'm going to do here is open up a new branch. I'm going to call this branch, we'll just call it test slash my test, just to be kind of cryptic. And then I've got my new branch. I can commit my change. I can say new title. And then I'm going to push my branch. That's going to ask me in VS Code, would you like to publish this branch? Yes. It's going to push it up to GitHub. So far, nothing about this is involving static web apps. Down here, it's saying, would you like to create a pull request? I do. So when I create that pull request, it's going to ask me here, do you want to create that from, I always check these over, the test branch here to main? Yes, that's what I want. I click on create. And now let's go back to our application and let's click on the code in GitHub. We can see there's a pull request right here called new title. And you notice there's this little yellow circle next to it. It's actually running a build. Because I created a pull request, if we click on this, we can now see there's a bunch of checks happening. This is the Azure Static Web Apps workflow with GitHub Actions. It's building the application for us. But wait, I don't want to overwrite what's in production, right? I don't want to change my initial message there because I was just testing this out. So let's see what happens if I go into here. What I can do is I can click on the details of any one of these. And it brings me over to the actions. I'll go full screen here. So you're seeing it setting up my job and building the application. And now we're going to watch this. The first thing it does is it creates a container in the background to set up the place to build everything. And once it does that, notice you're seeing here, ooh, I found your app directory. That's Svelte app. And it found an API. That's great. So now it's going to configure everything to get ready. We're about 1 minute into this job. And remember, the last time we ran the job, it took 2 minutes and 2 seconds. So it's going to be around that time frame. Now it's actually going to go through and it's going to set up Node and NPM, do our NPM install, and see what can happen for us. Now we have a failure. So if I click on the failure, we can see what's happening. We come through here, we can see we have a bad request. Now, if we're looking at this one here, it's saying the static web app was no matching web app was found or the API key was invalid. What this means is I didn't set up a brand new static web app for this. So therefore, I got an error when I created it. Whenever you get this error, it basically means that something happened. And what happened for me, and I wanted to point this out because it might be something you run into, is I recently changed my branch from master to main. And when I did that in the portal in Azure, it knows the thing was called master, but it didn't know I changed it to main. So therefore, I got something out of sync. So I have to go back into the portal and tell it that it's actually pointing to main. I'm not going to show you how to go through all that right now because that's just minutia. But if you run into that, that's what that error message often means. For us, if I hadn't have done that, it would have rebuilt the application, created a preview URL, and it would have launched it. So we have two URLs running, one with welcome and one with goodbye for the application. The last piece I wanted to show you was the authentication and authorization in the app. Now remember in the app, we have these authentication authorization sides. So we've got our list and our discounts, which we can access. Well, if I log out, I can't get to either one of those. And the way I'm logging in here is I can use out of the box Twitter, GitHub, or Azure Active Directory. You can also set up custom authentication as well. And there's documentation on this. If I set up GitHub, you'll notice what's happening is I get access to, it knows I'm John Papa, and it sees I can get access to the list and discounts. Let me log out, and I'm going to go in as Twitter. So now Twitter's asking me, who are you? There's my Twitter ID and my password. I'm authenticating. Now I've got a TFA code that's coming to me from somewhere. I entered the wrong code. It's because I got to check my text message. It's not texting it to me, so that's okay. All right, so we're going to get back out. Choose a different two-factor. Let's go to text. There it is. You guys can all see my code real quick. Now, when I log in with Twitter, you'll see I've got this list is working, but the discounts are not. So why is the difference in behavior? With GitHub, I could see everything. With Twitter, I couldn't. Now, what's going on? So I can see both here, but the difference is back in the portal. So if we go back to the portal itself, we have to find our button to get there. There it is. We'll go back to Static Web Apps, Shop at Home. There's another button here for role management. Notice in the role management, I've got John Papa at GitHub set up, and that's giving me the identity here of preferred, anonymous, and authenticated. Preferred users in my application are automatically set up to be able to get to the discounts and the list. But if you're not preferred and you're only authenticated, you can only get to the list, which is why Twitter is not on that list, so therefore it can't get the discounts. But GitHub could. So if I go back to GitHub, notice I can have access to discounts. That's because it's in the preferred role. So what I can do is I can invite myself with something like Twitter. I can type in my Twitter ID and the domain. I have to pick which domain I want it for. I could do www.shopathome.dev. I could give myself the role of preferred, generate this link. I could email it to somebody or give it to them, and if they click on this link, it'll automatically add Twitter as one of those identities. So I want to do that. I can just copy and paste it in here since that's me. And now I'm logged in as Twitter, and I've got my list right there. And I've got it cached, which is happening in this one. Oh, hold on, let's go back. Did I close it? Let's refresh it. There we go. John Papa, preferred, and it's a caching issue, but it allowed give me permissions to go to both of these places. And I don't want the Twitter one to exist long-term, so I'm going to delete that one. So you can manage your users and your roles right here from this page, which is kind of nice. Now, the magic that makes that work is like, where do you set up these rules of who can do what in your app? If you go to the Static Web Apps config file, this is a custom file that you can create with Static Web Apps. And what it allows you to do is set up special routes. Some of these routes are just redirections. But what others are, like this one here, it says, okay, if you want to get to products, all you have to do is be authenticated, which is kind of redundant. I'm just doing that to be explicit. So as long as you're authenticated, you can see the products. However, you have to be in the preferred role to get to the discounts. That's my rule. Doesn't matter what you're trying to do, you can't get there otherwise. You can get to any other API route you want as long as you're authenticated. Then I have a rewrite here. It says, or redirect. I want when you log out, it's actually going to go to this URL, just because under the covers, that's a little uglier. So I like to say log out. You can do pure redirects as well to HTML content. You can also have a specific status code come back if somebody tries to go to a specific place. In this case, we're saying, I don't want you to allow the Azure Active Directory login, so therefore return a 404. Now, in any of these web applications, they have something called a navigation fallback. So if you want somebody who goes to the wrong address, for example, we go to shopathome/John Papa. That's not a page. Well, the behavior I want is it to go to this page here. What's happening on the server, remember, is it's looking first for a file called johnpapa.html. Well, that doesn't exist. So unless I code this properly, the Svelte app is never going to run, or the React app. I need a fallback to say, I found a bad page. I want you to load the Svelte app and then let its routing kick in. And that's what these navigation fallbacks do for Angular, React, Vue, and Svelte. So here we're saying if somebody finds a 404 basically in the back end for an HTML page, automatically pass the index.html up and let the front end framework handle it. But we're going to exclude things like CSS and image files. And there's just some other kind of overrides that you can put in place if you want to. Like if somebody tries to get to a page in the server that doesn't exist, you could also do a custom 404. So there's a lot of control over what you can do. For the authentication, the reason I couldn't see anything for discounts is because unless I had that preferred role, you can't go anywhere. And this is just a file with a special name that you put inside of your distributed artifact folder that gets deployed, and Azure reads that so it knows how to read your rules. Now, this does not get exposed up on Azure, so people can't change it. This is something that Azure will then take and use for your application. So cool. Let's get back into the slides, and we can wrap up where we are. Oops. Looks like I lost my slides. I guess I'll go open them up again. Here we go. There they are. So we had all those things that we just took care of. We had www, we had custom domains, we had SSL, we had an API, we had a reverse proxy, we had CI/CD, we had CDNs, points of presence. What else do we have? Authentication and authorization and SSL. Azure Static Web Apps handles all that for us. The nice thing is we just write the app, it globally distributes it, it handles the security for us, gets us our SSL. We just point it to our custom domain and it handles the rest. It integrates with Azure DevOps or GitHub, your choice for CI/CD. And you get an integrated API if you want to use that too. And you can also get those staging versions that we talked about, or preview URLs for pull requests. And all that's out of the box. My favorite part is you can choose whatever web framework you like, React, Angular, Svelte, for example, and then deploy that to Azure Static Web Apps. So once you have the application that you want to use, and you can test this out right away, if you want to try this at home, here's the links that you can try. There's 3 to remember. The first one is the Learn link. Learn is a tutorial. It's a hands-on tutorial where you can learn how to do everything I just showed you and more. So it'll walk you through creating an application, deploying it to Azure. No account required. You just need to go into the application. I even give you a sample app that looks just like what you're seeing here, so you can deploy it yourself. And you get to pick whether it's Angular, React, Svelte, or Vue. If you want to learn more about what you get with Static Web Apps, you can go to the docs page at the second link. And let's say you're not using one of these 4 frameworks. I've got a repo that I created, the community is contributed to, and I believe there's 41 different frameworks in there. It's this Hello Worlds repo. And if you go check that out, bring that over here. You might be using one of these frameworks. You can use any one of these to try it with Azure Static Web Apps. Blazor, for example, or Babylon, Aurelia, Gatsby, Flutter, Knockout, Marco, Polo, Meteor, any of these. So it's a lot of fun to check these out that are up there in the web. And the last thing I'll show is that once you try this, I find one of the pages that's most useful is the docs page. And right on the second page on Overviews, hosting plans, it shows you what you get for free right out of the box. So you can kind of see you get the web hosting. I mean, everything I showed you, you get for free. If you want, you can go to a paid plan and it gives you a little bit more as well. If you want to bring your own functions or your own authentication providers, for example, or if you want more than those 2 extra custom domains, you can go to 5 if you like, and there's a paid plan for that. But what I love is out of the box for free, you get everything I just showed you, and it's really quite a lot to take off your plate when you're building applications. So the end of our story is, what do you get? You get to write code and deploy it and not have to worry about all those things we talked about. So hope this is exciting for you as it is for me. I'm really happy because this solves a problem that a lot of web developers have these days. And if you have any questions, I'd be happy to take any.
Yeah, that's normally my cue to start with a lot of questions that popped up in the chat or even in my head. But I have to admit that you basically already won me over when you said Azure Static Web Apps allows you to focus on the code. And that was my cue going like, oh, okay, this is awesome. I can now just focus on what I love to do and not worry about all the configurations that I have to do to make it happen. So that already won me over. And definitely that link to the page of what do I get for free really nurtures the Dutch in me. So thank you for that.
Of course, yeah. I really like the authentication part. Really, really awesome features. Yeah, great.
Awesome.
Yeah. So we didn't have any questions in the chat, right?
No,
And also no Disney fans in the chat.
no, apparently not.
No.
Oh, no.
Yeah. So no questions for you, John, but really great presentation. Thank you very much for being here and showing these awesome features. And oh, there is one question?
I adore static web. Question about authentication. Does it get passed to the functions?
Does the
Whether the
authentication...
authentication gets passed to the functions itself within the Azure Static Web App.
So are saying, would you... Yes and no. So the authentication lets you basically look to see if you can secure the functions at the front end, so you can't even call those from the authentication if you want to. But if you want to use and actually inspect the identities inside of those, there is a way to do that, but it doesn't automatically happen. Probably a deeper discussion with the docs you'd have to look at.
Yeah, because this sounds like a very interesting use case to provide single sign-on for additional functionality in your web apps.
Yeah, that's really where that custom authentication provider I mentioned, which comes with the standard plan, where you can do a little bit more with that. But I'm not 100% sure on that. I haven't tried that yet. It's something I've been itching to do because I have some functions that has different authorization than the app does, and I really like to see how that works. So I'm going to tell you, I don't know the exact answer to that, but I think you can do that with custom authentication.
Yeah, and you can use claims principal binding data to show all the claims inside of your function.
Yes.
Yeah.
Wow.
Yeah.
There's a whole new world to bring back the Disney theme.
It is a whole new world, yes. Or Star Wars, if you like that. So.
Okay, great. Thanks a lot, Jan.
Thank you so much, everybody.
Have a great day.
Yeah, you too.
Thank you very much.
So that means that our Azure Thursday, our last full virtual Azure Thursday has come to an end. So thank you all for joining again, and hope to see you next month on November 2nd in the Jaarbeurs in Utrecht to join us with our Ignite viewing party. Hope to see you there.
Definitely.
Bye-bye.